Hello everyone, this is Key. Today we're going to talk about Lab 7. In Lab 7, we introduce two typical AC circuits, which are RC and RL circuits. They are built by capacitor and inductor. In this video, I will just cover the important concepts, but it will be also important for you to read the manual by yourself. The first thing I would like to talk about is capacitor. So a capacitor is a component that stores electrical potential energy by means of an electrical field. The main point of this lab is to know the charging and discharging process of a capacitor and inductor. Inductor. So for a capacitor, we said it can store the energy, and the relationship of the charge on the capacitor, which can also be seen as energy, and time follows this equation. This is an exponential equation, exponential function. So we can see the charge curve is like this figure. So as time goes by, the energy is increasing constantly as an exponential function, and after some calculation steps, we have this equation which describes the relationship between the voltage across the capacitor and the time it has been charging. Once the capacitor is charged, if we move the power source from the circuit at this point, the capacitor will start to discharge the voltage it has been stored to resist this change. And the relationship is also an exponential relationship and is governed by this equation. Shown in the figure here, as time goes by, the capacitor constantly discharges energy, so the voltage across it drops until zero. Another important component is inductor. It can also store the energy like the capacitor, but what's different is that for an inductor, it's through magnetic field, not an electrical field. Next important point is time constant. So what is it? Time constant, often denoted by tau. It is a measure of the time it takes for the circuit to reach a stable state. For a RC circuit, which is built by a combination of resistor and capacitor, tau is defined as the resistance in the circuit multiplied by the capacitance of the capacitor. Remember, this is the resistance in the circuit, which including all the internal resistance of the component used in the circuit. So now we have this tau, and if we substitute this into the equation here. So if we substitute tau for t, we let t equals to tau, which is equal to RC, and after the calculation we got this result. This means that when the amount of time equal to the time constant tau has passed, the capacitor will reach a voltage equal to 63.2% of the source voltage. Similarly, for a RL circuit, which is built by a combination of resistor and inductor, tau is defined as the inductance divided by the resistance in the circuit. And remember, this conclusion is also applied for a RL circuit.